Okay, so you were adding up some orders that came in at a cookie cake factory, and you found that you could do fractional amounts of cookie cakes. So someone had ordered 4/5 with one type of topping, I think it was M&Ms, and then 3/5 chocolate chips, 2/5 sprinkles, and 3/5 walnuts. So they're able to order these cakes by the fractional amount. Well, how many fifths of cake were completely sold? And so you add it up and you probably got 12. 12 fifths were the fifths that were sold. But then they said that's a little bit of a strange way to write that amount. How many full cakes were cookie cakes were sold that day? And what fractional amount of another cookie cake might there have been? And so you had to convert from an improper fraction to a mixed number. And so I like to think about the fifths. These 12 fifths, there's 12 fifths as if they were just scattered all over the table, right? And how many fifths does it take to make a whole? 5, of course. So every time I have 5 fifths, I'm creating a whole. 5 fifths. And with those 5 fifths, I can create another whole. How many fifths have I used up so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've used up 10 of the fifths. I had 12 fifths. Here's our improper fraction. I had 12 fifths. That's what this little model is. I used up 10 of the fifths to make the 2 wholes. But how much, I'm going to move this over a little bit. But how much fractional amount do I have left? I don't have a full cake. 12 fifths is the same as 2 full cookie cakes if I push those together. And 2 what's left over. What are those? If you forgot what they were, you can always check the denominator you've been working with because they're fifths. So there's 2 fifths left over. I have some clues about what the denominator is, a lot of different locations. I can look at the denominator in the problem, right? I can see that it takes parts to make the whole. Again, you want to keep how many parts it takes to make a whole in your mind because we're going to be converting from improper to mixed, but we're also going to be converting from mixed back to improper. So let's say all you saw was 2 and 2 fifths, which this is a picture of 2 wholes and 2 fifths of an additional whole. We don't have another whole cake. I don't have 5 fifths. So how many total fifths would be represented in this amount? Well, you know, because we just did it, but think about a procedure to think about if you didn't know that. You know you have 2 fifths for sure, but they want to know how many fifths total if you were to break this all apart again. And one of the tricks is to know how those wholes were made, how many fifths it took to make each one of the wholes. And I can see here, it took 5 fifths to make one of the wholes, and it took another 5 fifths to make the other whole. So these 2 whole cakes represent 5, 10 fifths, don't they? So if I can understand what fractional amount made each of these wholes, I'll be able to tell you 10 fifths made up the 2 wholes, and there's 2 more. So altogether, that's 12 fifths. So you want to be able to determine fractions made up those wholes, because that'll tell you how many of each of the units you have. I've got 5 of the 5th units, 5 of the 5th units to make the 2 wholes, and then of course the extra 2 fifths. But what if we just saw the mixed number and we didn't see the improper fraction? What if we just saw 2 and 3 fourths? And someone said, okay, I see we're working with fourths because we always get grounded with our denominator first, right? And they're asking you, okay, how many fourths is that altogether? If you were to take the 2 wholes and break them apart and put those 3 fourths out, how many fourths would you have altogether when they're not put together into wholes? And so I know I have 3 fourths, obviously, but what about these wholes? How many fourths? I know I'm working with fourths. If I could see inside, how many fourths made up each one of these wholes? Well, one of the wholes was made with 4 fourths, right? Another whole was made of another 4 fourths. So this 2 wholes were made of 8 fourths plus 3 more is 11. So 11 fourths. 2 3/4 is the same as having 11/4. This is improper form. This is called mixed number form. And it's just mixed number because it's part whole number, part fraction. It's a mix. It's not just one thing or the other. So it's a mixture. Okay, so B, we're going to be working lots on converting back and forth from mixed numbers to improper fractions. So the trick to that is to know what fractional amounts make up the wholes. And the denominator is right there. If you forget, look there. This tells me that everything in this problem is made of fourths because that's the denominator. Power of the denominator, right? You're used to looking at that and relying on the data you get from it. So we'll be getting super strong in these.